This is lesson 3.2. In this lesson, you're going to estimate products, which is the answer to a multiplication question, and quotients, which is the answer to a division question. And these estimates are going to be working with decimals. So what I'm going to be doing basically is I'm going to give you a divide question and a multiplication question with decimals, and I want you to estimate the answer. So let's start with what is an estimate? Well, an estimate is a guess. Now that guess has to be close to the exact amount. Okay. Now, for example, let's take a look at where I live is in a town called Sedgwick, and there are nearby towns called Killam. So the distance from here, from Sedgwick to Killam, is around 10 kilometers. So if I was to ask you what would be an estimate of the distance between Sedgwick and Killam, I would expect that you would have to have some knowledge about the distances between towns and the local area. If you're not from this area, you can't tell me what the answer to that question is, so you cannot really even make an estimate. However, if you are from this area, you should be able to tell me, probably very accurately, what the distance is, because it's a very commonly traveled route. So 10 kilometers would be fine, 8, 11, 12 will be good, 15, a little too far, 20, definitely out. All right, so is there a wrong answer? Well, yeah, there is. It's not 100 kilometers, all right? Your estimate should be around 11 or 12 or 9 or 10, but it could not be 1 kilometer and it could not be 5 kilometers. So that brings us to the question, how do you know when your estimate is right or wrong? Well, here's the problem, or here's a solution, I guess. You have to use common sense, benchmarks, and your own personal knowledge in order to do this. If I ask you a question to estimate, and you don't know what it is, for example, in Great Britain they use weights in stones, all right? And if I asked you, okay, I want you to estimate uh, the the weight or the mass of an elephant in stones, please. Now that's a question which you probably cannot answer because you have no understanding of what a stone is in terms of weight. All right, but you do know what it is in pounds and in kilograms. So those two things you should be able to make an estimate in. So what is a benchmark? It says you have to use common sense and then a benchmark. Well, a benchmark is a piece of information that you are sure about. Okay, so for example, the distance from here to Killam being 10 kilometers, if you knew roughly that all the towns down the highway were 10 kilometers apart, that would be a piece of benchmark information that you have. Okay, now estimates are either overestimates, which is too high, or underestimates, where the information is the estimate or the guess is too low. Sometimes you want to overestimate. So for example, if you go shopping and you don't want to be embarrassed when you pay for things, you want to make sure that you overestimate the cost of the items that you're purchasing. So if you would round everything up, so to make sure that when you got to the cashier that you had enough so that you could pay for it all, and then you wouldn't have to put anything back. What about an overestimate? Well, under that's interesting. I've got overestimate and underestimate there. Yeah, okay, this is an overestimate. So this is an underestimate here. So that should be underestimate. So underestimates could be used when you calculate how far you can travel with gas in the tank in your car. You want to underestimate the mileage so that you have enough gas. If your car will travel 25 kilometers on a liter of gas or whatever it takes, and you know how far you have to go, you can actually make an underestimate to make sure you have enough gas. Okay? Now, estimates are used to check on calculations, and that's their primary use in mathematics. So, for example, when you get a question, a word problem, and you do the calculations, what you need to be able to do is, in your head, very quickly, take and do an estimate to find out whether or not the calculation that you have completed is actually makes sense to you. So here's an example. John has a board that's 8 meters in length. The length of the block he lives on is 150 meters long. How many boards long is that? Now, if you use your calculator, you should know that to find the solution, you just have to take the length of the block, 150 meters, and divide it by how many 8-meter boards you would use. So you'd be going 150 divided by 8. So we know that you're supposed to do division. So here's what we'd have to do. Now, you would get 150 divided by 8, which is 18 and 75 hundredths, almost by point there, boards that you would need in order to go from the one end of the block to the other. So this tells John that he would need 18 and 75 hundredths of a board. Now, how do we find out if he's correct, or if we've made a mistake? Well, we can do an estimate. Okay? So how do we estimate? Well, the first thing you're going to do is you're going to choose a number that's easy to divide with, that's close to the 8-meter board, and you could use that to divide. So for example, 8 is very close to 10 meters. So instead of using an 8 and dividing 150 by 8, I would divide 150 by 10. And this is an easy division. 150 divided by 10 is simply 15. So the question is my 15 close to what answer I got? And you can see here that since I rounded the 8 up to a 10, it's going to decrease the amount of boards I need. So I know I'm definitely going to need less than 18 boards now. And if you look at my guess, you'll see that my calculation, or my estimate, 15, is very good. It's very close to what I need to have. So I know because 15 is my estimate, and 18 and 75 hundredths is my number that I got in my solution, that there's a very, very good chance that my calculations are correct. Now, is this an overestimate or an underestimate? Well, in this case, it's under, because I took the 8 and I rounded it up to 10, and that's going to make the dividing have a smaller quotient, okay? So it's going to be less than the true value. All right, well, what are some examples when you would use estimation? Well, we did shopping and traveling and most math problems, but there's also times when you would not use estimation, okay? Like, for example, you'd never want your doctor to estimate your medication, all right? You would want him to make sure he calculated everything properly so you didn't have any difficulties when you took that medication. There are three types of estimating that we're going to look at. The first one is called front-end estimation. This is the quickest method, but it is also very inaccurate sometimes. The next one is called a decimal benchmark, and that's where you find the number that you're comfortable working with. And then the third one is called compatible numbers, and this is where you actually go to a number that you know you can work with. And it may not necessarily be a benchmark, all right? Sometimes compatible numbers are your benchmark, so that's pretty good. I mean, it makes it easier to work with. So the first type is called front-end estimation. Now in front-end estimation, you're only going to use the first 1 or 2 digits of each number to get an estimate. It's not always the most accurate type of estimating, but it is definitely one of the fastest. For example, what is the sum of 23,463 plus 12,324? Well, the first thing I'm going to do is I'm going to round the two numbers off to the first digit only. So my 23,463 is going to simply become 20,000. This, 12,324, I keep the 1 and everything else turns to a 0. Now when I add 20,000 and 10,000, it's very easily 30,000. So I know that my answer should be around 30,000. Now that one works really well. That's not a bad example. However, if this was 19,000 and I rounded it off to the first digit, that would become 10,000. So that would be a significant difference from where the true value is and my rounded off number. And this is where you get some problems with front-end estimating. Okay, you can be in front-end estimating, if you're not careful, you can be very inaccurate. All right. Now, is this an overestimate or an underestimate? Well, in front-end estimating, because everything after the first digit turns to 0, or what ends up happening is you're always decreasing the number. So that means it's always going to come up underneath the value. All right, let's use some front-end estimating. So what I'd like you to do is to take and do these 3 questions by using front-end estimating. And I guess I've already mentioned, I guess I forgot to cover up the under over here, so you get some free answers. So pause the recording and do these 3 front estimations, please. Okay, well, first thing I'm going to do is this is going to become 20, and this is going to become 3. All right, so my calculation is 20 times 3. Well, 2 times 3 is 6. Add the 0, so this answer here should be around 60. Okay, this one here, 12.89, that's going to become 10. And 3.2, that's going to become 3. So this one here, 10 divided by 3. Well, we know that 10 divided by 3 is roughly 3. 3 goes into 10 roughly 3 times. This one becomes 145. That's going to become 100. And the 13 will become 10. So you have 100 plus 10, which gives you 110. Now you notice that each one of these cases, every number was decreased, right? Now this one here is actually not very close to 60, all right? This is actually supposed to be close to, well, this is very close to 30, That's very close to 4. So this is supposed to be 30 times 4, which is 120. Because we round downwards using front-end estimation, there is a significant difference in our estimate and what we're going to use. So this is a situation where you would never want to use front-end estimating, because 28 should not be dropped down to 20. You should take 28 to 30. And 3 and 8 tenths should never be taken to a 3. It's too close to 4. So this should have been 30 times 4. Now, 30 times 4 is 120. That's a big difference between 60 and 120. So this is where we have to introduce the other types of estimating. So the next one we're going to talk about is called decimal benchmarks. Now, a decimal benchmark is a decimal that is close to the numbers you're using, and makes it easier to perform the mathematical calculation. You usually round with benchmark estimates to a number that's easy to work with. You can either round up or you can round down. So here's an example. A glass bead weighs 2.2 and 15 hundredths of a gram. How many beads are there in a pile that has a mass of 38 and 7/10 grams? So the decimal benchmark I've got to do here is I've got to make something close to 2 and something close to 38 so that I can do the math very closely. So the decimal is very close to 2, is I'm going to choose 2. I'm just going to round it off to 2 because 2 and 15 hundredths is very close to 2. Now 37 and 7/10, that one rounds up to 40 very easily. Now the reason I chose 40 is because 40 divided by 2 is an easy math question to do. Half of 40 is 20. So a good benchmark, 20 B's is my estimate. Now, is this an overestimate or an underestimate? Well, it depends on what you want to look at here. We've rounded the 38 up to 40, and we've rounded the 2 down to 20. So one went up, one went down. So this one's going to be very hard to tell. It's going to be very close, right? If we'd rounded both of them down, then it would be an underestimate. If we rounded both of them up, it would be an overestimate. But in this case, because one went down and one went up, we know we're going to be very close. Okay, let's go to the next page. All right, use benchmark estimating. I want you to take and I want you to pause the recording and do these 3 calculations, please. All right, here we go. So 6 and 735 thousandths divided by 2. Well, the easiest math there is I went to actually 6 and 8 tenths, because I know that 68, if I just drop the decimal for a second, half of 68 is 34. So I can actually do a little bit more accurate one here than normally. Now, if you wanted to take it around this to 7, half of 7 is 3 and 5 tenths. So that would still work out very well. Okay, 21 and 647 thousandths and 6 and 2 tenths. That is 21. And I rounded this to 7. The reason for it is I know that 21 has a 7 in its times table. So 21 divided by 7 gives me 3. That should be an equal sign. All right. And now 7 and 98 hundredths divided by 3 and 88 hundredths. I'm going to take and change those out. This becomes close to 8. This is close to 4. 8 divided by 4, that's 2. So this is how you can use benchmark estimating. Now, compatible numbers are very similar to benchmarks. In fact, a lot of your compatible numbers are going to be the benchmarks that you like to use. Like they're numbers like 10, 20, 100, or 400, 500, 600, and you can see that they're very easy to work with. The key for a compatible number is to choose a number in your head that you can use. If you've got to write down and actually calculate it on a piece of paper, then you've defeated the purpose of doing estimating. Estimating should be done in your head. It should be done relatively quickly, so there's not a lot of work to it. So here's an example. Let's estimate the following. 23 and 64 hundredths times 2 and 6 tenths. So first off, I want to choose numbers that are easy to work with, all right? So I'm going to be going to 23, and I'm going to take 23, I'm going to round that to 25, because that's an easy number to work with. And my 2 and 6 tenths, I'm going to round that to 3, and 25 times 3 is 75. So I chose 25 because 25 is a quarter and 3/4 is 75 cents. So that makes the math very, very easy for me. All right. Now, 31 and 8 tenths divided by 7 and 4 tenths. So I'm going to take the 31 and 8 tenths. I'm going to choose 32. All right. And the 7 and 4 tenths, I'm going to choose 8, because I know that 32 and 8 are divisible. 32 is actually a multiple of 8. It's in the 8 times table. So 32 divided by 8 gives me 4. And the last one. 1 and 98 hundredths times 462. Well, I'm going to take this number here. It's very close to 2, so I'm going to round that to 2. And of course, 462, I'm going to round that to 500. And or you probably could round it to 450. Doesn't matter, whichever one you're comfortable with it. 2 times 500 is 1,000. 2 times 450 is 900. All right, the 450 is definitely more accurate. And if you're really interested, and you could do 460 times 2, that actually is even easier, or is even more accurate. Okay, it all depends on what you're comfortable, because these are your compatible numbers, not necessarily the person beside you. All right, so here's some examples we're going to work with. John has tickets to the symphony. He paid $189.56 for 4 tickets. Estimate the cost of 1 ticket. And I'm going to do both methods here. I'm going to use front-end estimation to show you, and I'm also going to use benchmark and compatible numbers to show you what's going on. So pause the recording, and I want you to do both of these estimation methods, please. All right, so front-end estimating. 189.56 cents. I'm going to take and change that. This is what I'm supposed to divide by 4, so I'm going to change that to be 100. Now you'll see 189 dropping down to 100. That ain't good. That's a big difference. So front-end estimating here would not be a very good idea. So you could use 180 divided by 4, but then you're starting to get into more compatible numbers and stuff. So front-end estimation in this case would not be a good choice. However, benchmarking compatible numbers, 189 is very close to 200. And 4 can be divided, 4 can be rounded up to 5, and 200 divided by 5 is 40. Or you might have just been able to go 200 divided by 4, okay, and that would be 50. So either one would work, okay? So basically we're talking about either $40 or $50 for 1 ticket. So if you did your calculations, you came up with around $40 to $50, you know you did it correctly. Frank went shopping, and he purchased 12 pop for his friends. Each pop cost $1.59, including taxes. Frank has $20. So if he goes to the store and he wants to buy 12 pop for $1.59, will he have enough money if he takes $20? So here we go with our front-end estimation. $1.59, and we have 12. So you can see right off the bat that we're going to have some problems here. 12 drops down to 10. That's not a bad one. But the $1.59 dropping down to a 1, that's a significant change. So 10 times 1 being $10. And I think we're pretty close here in understanding that $10 is not a very good estimation for this calculation of 12 times 1.59. Right? Now the benchmark estimations, it's the same type of calculation. Here's my benchmarks. Okay. Now for this one, I can multiply $1.50. I'm pretty good that way in my head. So for me, a benchmark is something I know. So 12 times $1.50 is $18. Now you probably are not able to do 12 times $1.50, and that's okay. So what you might want to do is take and say, okay, let's drop down the 12 to a 10 and the 159 to $1.60, because $1.60 times 10 is $16. So either way, 16, 18, we're both very close there. So in all cases, it looks like Frank is going to have enough money. All right. Now remember, we'd rounded this down a little bit, right? And we had $18. We rounded this down, rounded this one up, but rounded that one down, and we had 16. So it looks like Frank's going to be able to get his purchase with no problems. All right. Let's go into some geometry. I want you to estimate the perimeter of the following square. Now remember, perimeter is always all the way around the outside, okay? So when you're doing perimeter, you start at one location and you're going to go all the way around and you're going to add up the distances, all right? Now on most of these types of questions, you're only given, the information is given to you in 2 locations, like on one side here and the other side over there. Don't forget that when you go all the way around, you have to include the signs that are not labeled with the 10160, all right? So I've got 101 and 6 tenths or 60 hundredths on that side and on this side, that side, and that side. So since the perimeter is the difference around the outside, what I'm looking at doing here is 101.60 added 4 times. Now if you wanted to, you could also just do the multiplication. To do your estimation, 101.60 is very close to 100. So the best estimation is probably just 100 times 4. Now remember to include your units, so my estimation is around 400 millimeters. Is this an overestimate? Well, we started at 101 and we went down. So because we went down, this is actually going to be an underestimate. This 101.60 is actually higher than the number we chose to use in our estimate. All right, so what is the side length of a square that has a perimeter of 385 millimeters? So now what we're saying is we have a square now, right? And that square, when you take and go around the outside of it, starting here, and you go from here, down that way, down this way, not very accurate, you can see all the way around, we now know that that is going to be 385 millimeters. We also know that in squares, all four sides are equal. All right, so that means that I can use the fact that they're all equal to multiply by 4. Sorry, divide by 4. All right, all the way around is 385, and I've got to divide that into 4 equal pieces. So we're going to be doing 385 divided by 4. So to do this, our mathematics, what I'm going to do is I'm going to keep the 4 this time because 385 is very close to 400, and 400 divided by 4 is 100. So the length on each side of the square is going to be 100 millimeters. You notice I use compatible numbers here. I knew that 385 was close to 400, so looking ahead I knew I could divide 400 by 4 easily. If I wanted to, I could take the 4 and maybe change it into a 5 and then go 400 divided by 5, but that's getting a little bit more complicated. I like the 100 and the 400 to 4 because the 100 is a nice easy number to work with. All right, moving on. All right, here's a rectangle. Now remember, the area of a rectangle is calculated by doing the length times the width, complete with a spelling error, HT. All right, so we have the length times the width. So we know that our calculation is going to be 139.70 times 63.50. Now I'm going to take and change these into compatible numbers so that I can work with them. All right, now this is going to be a little more difficult because there's not many numbers around 139 and 63 that I can really work quickly with in my head, so I'm going to have to do some changes here. Now, I'm using front-end estimating here. The 139 dropped down to 100, the 63 dropped down to 60, so I'm around 6,000. But I also know that this is a serious underestimate because I dropped down 39 off of this to get to the 100. All right? I kept this close to 60, so I know that I'm going to be seriously under. So when I'm doing my checks, I know that the 600 should be well below what I'm normally doing. And if it is, there's a good chance that my area is correct. Okay, so let's do the next two here. I want you to take the questions on the left, the 3.2 times 4.1 and the 1.67 times 2.1. I'd like you to estimate these two values and then place a greater than or less than sign, I guess it's the other way around, less than and greater than, on the blank. So pause the recording and do the rounding of all of these 6 calculations and then put the appropriate inequality between them. All right, well, 3.2 times 4.1, I'm going to go 3 times 4, that's easy, that's 12. 1.6 times 2.1, I'm going to change that just to be 2 and 2, so that's around 4. So obviously, the 12 is greater than the 4. 116.23 divided by 2.87, so I'm going to round this off. You'll see I've got 120 divided by 3, that's 40. And the reason I chose 120 is I know that 3 times 4 is 12, so I can use that to find out 12 divided by 3 is 4, and then I can just add my 0. 21 times 1.35, I'm going to take the 21, I'm going to change it to 20, and the 1.35, I'm going to do a front-end rounding on that of a 1, and 20 times 1 is 20. So it's very clear that the 40 is greater than the 20. Okay, so start the assignment. If you have any difficulty, you can watch the video again. If not, come in and talk to me, and we will get all of your troubles sorted out. So we will see you in lesson 3.3.